All right. Hey, everybody. Mr. Fortin here. I'm going to take you through your homework right now. Now, this is the remainder of the slides 13 to 20 that you started in class today. So in class today, you should have had practice marking up where the starting number was on a graph, marking up how you can show where the growth number is on a graph of a line. Specifically, we're in linear relationships this chapter, and also doing that with a table, right? Doing that with a table and coming up with its equation using the table. Now, what you have for your homework tonight, where it's going to jump into, is basically writing equations from a graph, right? From a graph. So you've practiced how to identify starting number in a graph, as well as how to identify the change number in a graph, or the growth number in a graph. Those would be the same things. And you've also practiced coming up with equations using those numbers from a table, okay? Starting numbers here in a table, growth is here in a table. So I know my equation is this because it's in the form y equals mx plus b. So it's going to be the same thing here in the graph. It's not too much as things are going to change here. So here, you're not going to mark up anything on this diagram. The reason why also, too, I'm doing this for homework is because normally this is a group task, right? You have time, you can do it in class together, but we don't have unlimited time with groups. So because you're not doing this stuff with your groups tonight, I figured I'd have this video lying around in case you had questions, right? And you're not totally sure what to do because you're not doing it along with the group. Okay, so you're doing along with me, Mr. Fortin. Anyways, here we go. This one here, question number 8, it says, here is a new line. In order to help you write the equation of this line, what information would you look for in this graph? And I think the answer is here. We can't draw up on it at all, but I think from earlier you should know this, that the thing that we need to know to write its equation, right? We need to figure out the growth number, right? So probably at some point we need to figure that out. We got to draw our slope triangle in a second. Our growth number, we also need to know the starting number. Okay? And we get our starting number from the Y intercept, right? Where we cross our Y axis. Okay, so I think we're gonna do that on the next slide. So I'm gonna click submit, send that in for my answer. Please do that as well, so I know that you did it. And then it says writing equations from the graph. So that's what we're gonna do now in part 9 here, slide 14. It says write the equation to represent the line. So what I would do is what I was telling you earlier. And I forget what colors it told you to use earlier, but I'm gonna use red for the starting number here. And so our starting number, we got to go to our y-axis. And what our y-axis is the vertical axis. Remember, our x-axis is like our normal number line. Number lines are usually horizontal, so that's our x-axis. So this is our x-axis, right? We're getting bigger x values this way, right? 10, 15, 20, but we're getting smaller, negative. It gets more negative left here. So our y-axis gets bigger as it goes upward here. This is our y-axis. We're at 5, we're at 10, we're at 15. So where their graph, right, our graph is this. So when this is our new line, right, it says a new line here that we need to write the equation for. Our graph is the thing in blue right here. So the first thing we need to identify to come up with our equation here is the y-intercept, which is this. So this tells us what the y-intercept tells us. Okay, so I got my y-intercept, and it's right here. It looks like it's at 1, 2, 3, 4, 5. Okay, we're scaling by ones. It looks like our y-intercept here is at 0, 1. And what that tells us is that when x is 0, y is 1, right here. Our x-axis is here. So we go to the 0 x-axis, and I look up, look down. Oh, my graph is crossing when y is 1, x equals 0. So that helps me write out my equation. So my equation is going to start with this. Y equals, and I'm going to put the 1 over here. Okay? The idea is that y is going to equal 1 when x is 0. Okay? When x is 0. So I might actually just put an x right here, because if x were 0 right here, look, actually pretend with me for a second. If I plug in 0 for x, what would y have to be? 0 plus 1 is 1, right? So we would have a point at 0, 1 here. Okay? So this is sort of how I'd start writing it. Starting number goes here. But the one thing that's missing, so a lot of lines, right, can go through 0, 1, because it could be a much more flat line going through 0, 1. There could be a more steeper line going through 0, 1. There could be a negative growth line going through positive 1 right here. The thing that we need to find right now is the number that's going to go in front of x, right? The number that's going in front of x, or the growth number, or change numbers, we call it. Okay, so we need to figure out what this is, right? We know it goes through 1. There's our y-intercept right here, right? Our y-intercept is 1. We have a 1 right here. Now we need to find our growth number, okay? So I'm going to do it. I think Angela did her growth slope triangles like this. So I'm going to find this point here. We have a point that looks like at 2, 5. I don't know if you played around with that on the last slide. We have a point at 2, 5 right here. So this is going to go from 2, 5 to 3, 7. Okay, 3, 7. Let me go back to the last slide for a second so you can actually see that. So we got to figure out how our x's and y's are changing, going from 2, 5 to 3, 7. That's going to show us our growth here. Well, it looks like if these, remember the front numbers, so it's x comma y. Our front numbers are getting bigger by 1, right? We get bigger by 1 this way, and then our y's get bigger by 2, and then up 2. So we got to go over 1 and up 2. Or rise 2, run 1 is one way that you probably called that in the past. In middle school is how they kind of talk about it here. So anyways, let's do our slope triangle so we can figure out what goes here. And so I'm going to rise up 2, and I'm going to label that plus 2, and we run plus 1. Okay, run plus 1. So our y value got bigger by 2, because remember, we went from 5 here, right? This is y equals 5 to y equals 7. So plus 2. Y's got bigger by 2. X's just got bigger by 1. Here, this point is at x equals 2 right here, and we're going to x equals 3. So x got bigger by plus 1. And to write our slope, what goes here is our change number, which is rise over, and we can barely see it there because I have trouble writing on Desmos here, over run. Messy, which is 2 over 1. Okay, 2 over 1. And 2 over 1, obviously, right? That just 2 divided by 1 is 2. So that fraction simplifies to just 2. And there we go. We got our equation. Okay, we got our equation right there. So 2 things we needed was the starting number, and that was 1. And then the growth number, which was 2. And that was good to go. So when you have lines like this is the quickest way. So this is something called a graphing shortcut. Because remember, we can graph other equations and come up with their equations differently. We'll study how we can come up with equations of non-lines later, like curves and other exponential functions and quadratic functions. We'll do that later this year. But remember, lines are special in that we just need to remember this thing, y equals mx plus b, as our way of writing equations. Mx plus b. Okay, y equals mx plus b. A little bit messy here. Okay, so if we do it in terms of y equals mx plus b, it's y equals 2x plus 1. Okay, 2x plus 1. And we will explain in a second, but I might go back to the last slide for a second. So just to remind you that in the y equals mx plus b, right, we need to figure out parts of y equals mx plus b. The thing we need to figure out is b, and b is our starting number. Okay, that's where our starting number goes in the equation. So here's what you really need to memorize here. Right, my starting number goes at the end. That's after the plus sign, or maybe it's a subtraction sign if my y-intercept is negative. And then we also need to figure out our growth number. And our growth number is where m is in this equation. The growth number is the one that goes in front of x, because as x gets bigger, y gets bigger in this one by 2, right? So we multiply that 2 to x, and we go plus 2 every single time, as we see in a table and whatnot. Okay, got our equation. Explain how we got our equation, what you're unsure about. Okay, first step, 1, we found the y-intercept. At b equals 1, right? Because we had a point. Have a point, the graph at 0, 1. And this is the starting number, right? The y-intercept is the starting number. So you hear some people saying, find the starting number. Sometimes people say, find the y-intercept. That's important because that tells us what our b value is in y equals mx plus b. Step 2, we found the growth number. Well, growth number is something called slope. We'll use that word a little bit later. The growth number by drawing a slope triangle that had a rise of 2 and run of 1. So growth is 2 over 1, which equals 2. And that equals m, right? That's our m. Step 3, substituting what we've determined for, we have a b, substituting b equals 1 and m equals 2, right? b equals 1 up here and m equals 2 down here into the formula, right? This is a slope-intercept form formula. Y equals mx plus b. Right, don't forget to share what your final equation is. We have determined the equation of this line to be y equals mx plus b. Let's see if I can put that in bold. I don't know if you guys are able to do that. No, you're not. Have that as the answer. Okay, take a second, pause. Email me any questions if you have any. Pause, read it. All right, ready to move on? Ready to move on? I think so. I think so. Let's just get through this homework together. Let's hang it out. Let's do it together here. Okay, writing equations from graph. Here's a new line. Write an equation to represent this line. So let's do this a lot quicker. I did that one. We'll do this one together. Guys, what's my first step? What's my first step? What am I doing right here? I got to find my y-intercept. I got to find my y-intercept. So let's do that. This is my y-axis, okay? So I look up, I look down. So it looks like we're hitting this graph is just a little bit below the x-axis where it hits right here. So I have a point at 0, -1. When x is, right, this is our x-axis here, okay? So when we get our x-axis, when we go all the way to 0, when x equals 0, our y value is -1 right here. Okay, that's good because that means -1 is our b value in y equals mx plus b. Okay, so that's good. So maybe I'll actually write y equals mx plus b up here. Oops, y equals mx plus b, really messy. I apologize for that. I think we can kind of see it there, y equals mx plus b, because I'm gonna write my equation right below it perhaps, and maybe I'll do that in blue. So I can do this, y equals, and let me put my x here. So y and x are always going to be in your final equation because y and x are called the independent and dependent variables, right? Those are variables that stay in the equation. X is going to change, and then y changes a certain amount. And then m and b are something called parameters. We'll study what parameters are a little bit later, but m and b get replaced, right? What makes an equation is that you have an equation relating x and y. That's why it's called a linear relationship. It relates x and y, and the way the x and I are related are changed by whatever your intercept is. So here, b is -1. So I'm going to start by putting my b into this equation, and that's going to be -1. So I'm going to have x minus 1 right here, which is good because if x were 0, then y, 0 minus 1 is -1. Y would be -1. Good. I have an intercept at 0, -1. Okay. Then I need to describe the growth, though. I haven't actually done that in front, so we need to do that really quickly, which I will do in green perhaps this time around. So I can do that directly. I can do that directly from the y-intercept, but I'm not going to do that because it looks like we're set up maybe up top here. So this one's pretty good here. I got a point here at 1, 2. That's not a 2. This is a 2. And I got another point here at 2, 5. So if you mark up the points, you can actually kind of figure out what your change number is a little bit here, because it looks like here are x's. Look, x's goes x comma y, or x's got bigger by +1. And I'll draw that in to the slope triangle right here. Okay, rise over run. So our run here, so rise over run, right? We always run to the right because that's how x gets bigger. So we're running to the right. And that means x gets bigger by 1 if we're here and going to this point right here. X gets bigger by 1, but y gets bigger by 1, 2, 3. There we go, by 3, because we go from 2, a y value of 2, oops, y value of 2 up here, right? A y value of 2 up here to a y value of 5. So rise over run is 3 over 1, and 3 over 1 equals 1. Oh, sorry, 3 over 1 equals 3. What am I talking about here? 3, we have $3, we split it one way, that means that one person gets $3, and we're good to go. All right, so what we got to do is we got to replace m with that 3. Look, m equals 3 right here, and I got 3, and there we have it. We've got it done. We have our final answer. So just take note here, guys. This is like one thing I'm pretty serious about. So in your final answer of an equation, what are the letters that remain there? It's a linear relationship because it's a relationship between x and y, an independent variable of some kind, and a dependent variable that depends on this independent variable. Anyways, x and y are the independent and dependent variables. We'll talk more about those later. And they rely on each other because they have a starting value of some kinds, and then there's a constant growth of +3 over 1. Okay, so the 3 replaces m, -1 replaces b, and that's it. We get y equals mx plus b, and our final answer is y equals 3x minus 1. Okay, are you unsure about anything? Write your questions here. Mr. Ford is feeling pretty confident about this. Are you feeling confident about it? Put your questions down if you have them. All right, little things change here. Ooh, this is maybe a big thing changes here. Is it still a linear relationship? Sure as heck is. Okay, linear relationship. What do we see at the beginning of linear? We see L-I-N-E. How do I know that word? Line, right? Linear relationships are lines. Okay, so this is a linear relationship in terms of how x relates to y, right? Relates to x to y. Okay. here, let's just do it. Let's come up with the equation. So we did kind of an I do, which was really fast. Sorry, really slow. And then I did a we do a second ago, which is a bit faster for the last one. And this is going to be a very quick one. This is a you do. Hopefully you can do this one on your own. Check yourself here before you wreck yourself, though, because this line is no longer going this way, right? We changed directions. We're going down that way. So we got to think about how things change here. Anyways, going real quick here. B is, oops, we got a nice little circle here that time. Oops, didn't happen. B equals 5, right? Because we have a point at 0, 5 right here. Got to get the change number then. Okay, so it's rise over run. Remember, it's rise over run here. And look, our rise, so remember, we always rise to the right. Sorry, we always run to the right. Always run to the right because X is getting bigger to the right side, okay? So as the way we talk about the independent and dependent variables is as the independent variable gets bigger, what's happening to the dependent variable? Because the dependent variable depends on the independent variable. So anyways, X is the important variable, right? X is generally the important variable because that's the horizontal axis. And remember from earlier in math, when you're an earlier math student in middle school, you were looking at number lines that were all kind of horizontal, right? All kind of horizontal. So we have one number, right? Let's call that one number our independent variable. And then if we're going to add on a second number to see how like the two numbers relate to one another, we'll call the vertical variable be the dependent variable. It's going to depend on this one here, okay? So we're always running to the right side, right? Running to the right side here. So that should tell you a little bit about how we have to go from this point to this point, okay, to this point here. So the deal with this one is that we're going to start at 0, 5. This is 0, 5. So remember, the y-intercept, the value is the value of x when x equals 0. What's the value of y? So we have 0, 5 here. And then we got to get to 1, 1. Okay, so we have our b value already, right? It's 5, right? We see the b value right there. And now we just need to get the growth value, and then we have the equation here. Okay, so as we go from 0, 5 to 1, 1, our x is going to get bigger by 1. Look here, x changes from 0 to 1. X got bigger by 1. How did our y change? We go from 5 to 1. Oh, interesting. We got smaller here. So what we need to do is we're going from 5. How do we get from 5 to 1? What would we have to do to 5 to get to 1? We would have to subtract 4 from it. So we draw down 1, 2, 3, 4. Negative 4 there is our change in y. Our rise is actually a drop, right? A rise of negative 4 is a drop of 4. Okay, so anyways, negative 4 for our rise, and our run is plus 1. And that means our slope is negative 4 over 1, or, right, negative 4 is split one way. Yeah, we owe $4, and we're going to split this to one person. That means that one person owes the $4, right? Negative 4 here for the m. Last thing to do is to write your equation. Okay, so let's get our equation down. And our final equation is going to be y equals negative 4. I almost wrote 5 there. That was dangerous. Negative. Make sure I can clearly see the negative for x plus 5. And I have this in red right here because that's where what I've been marking all my starting numbers as. And my growth number is over here, negative 4, okay, for my growth number. And that's it, right? X and Y appear in our final answer. It's just M and B change, right? Change because those are the parameters, not the independent and dependent variables. The independent and dependent variables are X and Y. M and B are something called parameters because they kind of tell what your line's going to do, right? You know you have X and Y in there and you have no exponents or whatever. You know it's going to be a line, but negative 4 is going to tell you what the growth is. And 5 is going to tell you what your y-intercept is. And then, hey, there we go. We have the way we classify this linear relationship. This x relates to y because if we have an x value, we got to multiply it by negative 4. We got to add 5 to it, and that's going to tell the corresponding y value. Okay, so for instance, when x is 2, right, 2 times negative 4 is negative 8, plus 3 would bring us from negative 4 plus 5, sorry, plus 5, negative 4 times 2 is negative 8, plus 5 is negative 3. Anyways, I have a point at 2, negative 3. It always works here. All right, describing the graph, how it's growing, add any question you have to this box. It is decreasing. So it's decreasing by negative 4, or by 4. Y is decreasing by 4 every time x increases by 1. And that's it, okay? So m equals negative 4. in that situation. All right, let's keep going here, guys. Man, I'm having a good time with this here. All right, this is kind of the last one that you have to work on here, but it's actually 3 individual slides. It'll be slides 17, 18, and 19. So let's check it out. Here, you don't have any grid lines. Oh, look at this here. They didn't actually put it in here. So they just gave you the points. Ooh, how are we going to figure out rise over run if they just give us the points here? Figure out how we're growing here. This pattern grows. Remember, X is the figure number, and Y is the number of tiles in the pile pattern. Anyways, how does this pattern grow? If the X represents the pile number and the Y represents the number of tiles in that pile, how many tiles are added from pile to pile? Okay, discuss with your group how many tiles are added from pile to pile. Be prepared to share, justify your reason. Okay, so it looks like here our X is the pile number. So in pile number 5, we have 17. Y is the number of tiles. We have 17 tiles in pile number 5. Pile number 6, we have 20 tiles. We have 20 tiles. So how much bigger do we get when our pile number increased one time? Well, 20 minus 17 is 3. Okay, so it's 3. So we get 3 more tiles every time, or from pile to pile, let's put each next pile, I guess. Okay, and well, every time, let's go to this. Every time the pile number increases by 1. I think that's a very specific answer. So we don't just go from pile to pile. It's like we're talking about from one pile to the very next pile, right? When we add 1 to the pile number, we're going to get 3 more tiles there. Explain your reasoning. Reasoning here, the rise is 3 and run is 1, right? Rise equals the change in Y, or the growth of Y, and run, oops, not run, right? Rise equals the change in Y, and run equals the change in X. So our Y's got bigger by 3, and our X's got bigger by 1. And there we go. That's how we're describing the growth. All right, slide 18 here. Let's see. It looks pretty much the same. It's a little bit different, so let's read it. If we wanted to write the equation for this line, we need the growth and the starting value. Discuss with your group what do you think the starting value is, and write it here. Justify your reasoning below. Oh, interesting. This one's actually a little bit trickier here. Check it out. Boom. Interesting. Ooh, this might be a little bit trouble for you guys to figure out right here. I got to think about this one. So we don't know for sure. It kind of looks like 2, right? 2 might be our guess. Is it 2? Well, let's see right here. What could you do? How are you thinking through this? Let's think. Think for a second. Think. Well, let's see. This slope triangle is going up by 3. How can we prove that it's actually going to be 2? Because I think it's probably going to be 2. It looks like 2, right? If it's going up by 3 and this is going up by 1, what we could do is, did you guys think about this on your own? Did you think about working backwards? All right, that's an important skill here in math, to be able to work backwards. Well, if we know this is 620 and we know this is 517, question, well, let's maybe put it in a table, actually. Let's put it in a table. X, comma, Y. And we have here 5, 17. Oops. And we have here 6, 20. Okay, 620. So we're getting bigger by 3 here. We're getting bigger by 3 here. The question is, how am I going to find my y-intercept? Remember, y-intercept is the one that's going to be next to when x is 0. Y-intercept is the value of y when x equals 0, right here. This is x-axis. We go to 0 here. We look up the y value when x is 0. That's what we need to find to get the y-intercept here, okay? So then the question mark is right here. This is what we need to find. So the question is, if we're going up by 3 this way, plus 3, and we can barely see that, but let's put a plus 3 here. How can we work backwards here, okay? Maybe you thought about this, and maybe I'll change color so you can actually see it a little bit more closely. But what I would do is this. I would take away 3 each time. So we need to get 4, 3, 2, and 1. And this is going to be very, very scrunched for space here. So if this is 17 and we go to 20, because we're going plus 3 this way, to go backwards, we just need to subtract 3, right? Subtract 3. That's what we need to do. So if not subtract 1, we need to subtract 3. So if we're going backwards, we can take 1 away from x. If we take 1 away from x, we need to take 3 away from y, right? That's the opposite of making plus 1, plus 3 over here. We can do minus 1 and minus 3. And that's what's going to allow us to figure out what all the other tile patterns are here. Okay, so this is 14. Look, that's 14, because 14 plus 3 is 17, right? You with me? 4 plus 3 is 7. 14 plus 3 is 17. 14 minus 3 is 11. Okay, and 11 plus 3 is 14. We're good to go. Okay, so we have another point at 311. Then we have another point at 2, 8. If I take 3 away from 11, I get 8. Take 3 away from 8, I get 5. And finally, if I take away 3 from 5, I get 2. Okay, I get 2. So my answer here is 2 for the starting number here. Okay, another way, alternatively, I could have done this, perhaps you did this too, is you could have just drawn it in here. You go down this, down this. If I'm going -3 this way, okay, I'm going -1 this way. So that means my next point right here is going to be 4, 14, okay? And then my next point here, I won't write it down, but I'm going down -3 from this is 11, and then -1 from that is 3, so 3, 11, and then -3 here, and -1 here. I would have another point at 2, 8, and then I'd have another point at, and I'm drawing my slope triangles too big, so 2, 8, -3, so it would be 5 for y, and 1 for x, so 1, 5, and finally -3, -1 from 1, 5 would give us 0, 2, okay? So 0, 2 is our y-intercept, so our starting value is 2 in this one here. So to recap, I'd probably set up a table. That's what I do. I put the 2 points in the table, use my growth number, and then I work backwards to get my y-intercept. That's how I do it now. There's going to be a faster way I'm going to teach you later this year, okay? Starting value is 2. Because we worked backward from 517, subtracting 3 from y values and 1 from x values each time until we got to 0, 2. And no questions for me. That's about the rest I have. Okay, really just the last slide here. Ooh, this is all my work right here. Check it out. Last slide for you guys is going to be this, and then you're just going to write any feedback you have on the very next thing. But this is really the last question you have. It says, here in the last few slides, you said that the growing number is 3. More tiles every time the pile number increases by 1. And the starting value is 2 because we worked backward from 517. Awesome, subtracting 3. Okay, this is what I said here. So we got to 0, 2. Anyways, it just says, write the equation for the line here. So I know my growth number is 3, y equals 3, so it's 3x, and I know my starting number is 0, 2. This is a 2 here. So y equals 3x plus 2. And that's my answer. Hopefully you guys got the same thing here. Do you have any other questions? No, I think I'm good to go. All right, how was today? Awesome. And you don't need to put this down, but you're welcome to share with me any feedback. And that's it for this assignment. Okay, let me know if you have any questions. Hopefully you guys watched it. I know come up with equations of line could be kind of review for you. It could be brand new, and so it's kind of hard to get the timing exactly right. But I appreciate you guys watching this video. Have a great night, guys. Bye.